This lesson is for FST, lesson 10.3 on the binomial theorem. The binomial theorem is a way that you can expand binomials without having to use FOIL or algebra. It's a really nice shortcut. The binomial theorem states that the coefficients, or the numbers in front of the variable, for the terms when you expand a binomial raised to a power are going to be simply combinations or a row from Pascal's triangle. The power that you end up working with your binomial ends up being your row number. So on our first example here, the row number is going to be 3, keeping in mind that when you count to the proper row, you want to start with the number 0. So this is row 0, row 1, row 2, row 3. So I'm going to grab the numbers 1, 3, 3, 1, and those are going to be my coefficients on my polynomial answer. So that represents the blue numbers here. 3 choose 0 is going to be 1, 3 choose 1 is 3, 3 choose 2 is also 3, and then the last one would be 3 choose 3, which is, of course, 1. Then you're going to take the first term in your binomial, which in this case, in both cases, is an x, and you're going to put the x there with whatever row number you're working with as your power. So in this case, x cubed. Then the next term is going to have one less power than that, so x squared, and then they just keep descending until you end up with x to the 0. Keep in mind that x to the 0 is 1, so we don't need x to the 0. Do the same thing with the second term in your binomial, which in this case here is a y. You can either start here and increase the power or start on the right and decrease just like you just did. So y cubed, y squared, y, and y to the 0. Last step is just to fill in plus signs and do any simplifying that needs to occur. Usually there'll be some multiplication that you'll have to deal with of multiplying numbers together so that you have a single coefficient up front. 1 times x cubed is just going to be x cubed. 3x squared y is not needing to be changed at all, so that's going to stay the same. This one I'm just going to drop the 1. I don't need an x to the 1 there. And then again here I don't need the 1 because 1 times y cubed is simply y cubed. I'm going to go ahead and circle my answer now because it is in standard form. All polynomials should always be written in standard form. What that means is alphabetically take the first variable that you're working with, in this case x, put the highest exponent first, and then continue to work with that same variable and decrease the powers until they're all finished. So if we look at the x's, it goes x cubed, x squared, and then plain x. Those are in descending order, so those are in the order that I wish them to be in standard form. The only other term that I have left is y to the third, and what you'll notice here is that the y to the thirds are in reverse standard form order, and that's okay because x comes before y in the alphabet, and so if the x is in the right order, I don't care about the y's. So that's our answer. Keep in mind that that would have been that is a lot more efficient than having to do the old-fashioned way when you first learned how to expand, of actually multiplying out 3 of those binomials. Remember, back when we learned it in algebra, you would have had to do FOIL on the first 2, take your answer, and distribute it to the x plus y. So that would take up a lot more time, a lot more energy, and to be honest, most kids do make careless mistakes somewhere along that process. It's very easy to do, and so this process of the binomial theorem eliminates all of that, and it gets us our answer in pretty much 2 steps. So let's just try a few more examples, just so you can get the hang of how these look. Our next one is x minus 2 to the 5th. So we're going to grab row 5. So I need the numbers 1, 5, 10, 10, 5, and 1, making sure that I have lots of room in between each of the terms. Then I'm going to grab the first term, which is still an x, and those exponents just decrease as I move from left to right. Now be careful here when I grab the second term in the binomial. It is a negative number, so you need to put that negative number in parentheses. And then you raise it to the power on the outside of the parentheses. Keep in mind here that negative 2 to the 5th is different from negative 2 to the 5th. If the power's on the inside, you could potentially get a different answer than if it's on the outside. So you do need to pay attention to where those parentheses go. Power goes outside the parentheses. Now the parentheses are just going to decrease or excuse me, the power is going to decrease. And then we're going to go back and simplify. Before I do that though, I want to quickly make sure I've got plus signs added in. So now you want to worry about the order of operations here. On the first term, we don't have much to worry about other than we can drop the 1. On the next term, I've got 5 times x to the 4th times x times negative 2. We are technically going to do the commutative property here and switch around the negative 2 and the x to the 4 so that those two can be combined to make a negative 10. Know that you don't need to show that step, but that's technically what's happening there, is that the x to the 4 and the negative 2 flip-flop, and then we just combine like terms there by multiplying. Be very careful on the next term and terms like it. We've got a power going on here, and that takes priority over the multiplication by the 10. Common mistake here is for kids to say 10 times negative 2 is negative 20 and then square that. The power comes first. Order of operations. So we're going to say 4 times 10, which is 40x cubed. Same thing here, we want to do the power first. Common mistake is for kids to say negative 20 cubed, but that's not it. It's 8. In fact, negative 8 times 10, which is negative 80. And then negative 2 to the 4th is going to be positive 16 times 4 is going to be positive 80. And then negative 2 to the 5th is negative 32. My x's descend starting from the left. There are no other variables to worry about, so I'm already in standard form. So much faster than having to do x minus 2 times itself 5 times. It does get a little bit trickier when both the first and last term in your binomial have numbers with them, especially when the first term isn't a letter like kids are used to. So we're going to grab row 4. I have row 4 memorized. I would recommend that you get row 4 memorized. It's easy to do because row 3 is so simple. Row 3 is 1, 3, 3, 1, so there's no reason you can't figure out row 4 from that. Obviously the first and the last terms are going to be 1. In the middle here you're going to get a 6, and I know that the first and the last, the second to last term and the second term in are going to be the row number. So row 4 should be an easy one for you to know. I grabbed row 4 because the power here was a 4. Now I'm going to go through and deal with my 2 first. I am going to put 2 in parentheses even though it's not negative, because if I didn't, it could potentially make it look like a 12 to the 4, and that's not what I want. So either use a dot there for times or parentheses. You do need to use parentheses when it is negative, so I'm just being consistent here by using parentheses even when it's not negative. And I just said negative, so that made me want to write a negative. 2 squared and 2. There is going to be a temptation here to try to figure out these numbers as you go and to write 8 by mistake or 4 by mistake. You wouldn't be wrong for doing that. It's just know that you are still simplifying. You're still setting up the problem. So trying to calculate too soon may cause trouble for you. So I would recommend just copying for now and laying off on trying to get ahead of yourself. Now we want to start from the right and do negative 3w in parentheses and then raise it to the 4. And then I just need to decrease my power as I move to the left. Then I go through and just add in plus signs in between all the terms. And now I'm going to simplify. 2 to the 4 comes before multiplying by 1, even though 1 doesn't change anything. So here I get a 16. Be careful here. Another common mistake is for kids to do 4 times 2 and get 8 to the 3rd and then multiply by negative 3. That is incorrect. You need to do 2 cubed. 2 cubed is 8. You still needed to multiply it by a 4 and by a negative 3. Keep in mind that you are not doing the distributive property here. You're not doing 4 times 8 and then 4 times negative 3. That's not how it works. It's just multiplication. So you're either going to do 32, which is 4 times 8, times negative 3, or you could do 4 times negative 24. You could do negative 12 times 8. All of those are possibilities here based on which two you decide to multiply together first. Regardless of which way you decide to go with it, you do have to get an 8 there and you do have to multiply by the other numbers. And when you do that, you get negative 96. There's only a single W there because there's no power. Here, make sure you do 2 squared and negative 3 squared. So we've got 6 times 4 times negative 9. Again, you can go in multiple orders here. Regardless of the order you go in, you should get 216W squared. If we continue on here, negative 3 cubed is negative 27 times 8. It's negative 216. And I happen to have 3 to the 4th memorized. It is an even power, so I know that the negative here is going to turn positive. So I get 81W to the 4. This answer, as it is currently, would be given partial credit only because it is technically not in standard form. It's in reverse standard form. So let's go ahead and rewrite it and put it in the proper form. So now it's in the proper form. I went ahead and circled it. Now it's in standard form. All right, students, it's time for you to try one on your own. Oh, before we do that, I want to point out one thing from the question we just did. This was brought up by a student in class, and I thought it was a really good idea. Because this one is in reverse standard form, we could actually take care of that way at the beginning here. Normally, if there's only one variable, you want the variable to be the first term of your binomial. If it's not, you're going to have it in backward standard form. So another option here, before we had even started, was to use the commutative property here to maneuver that binomial so that it says negative 3W plus 2 instead. If we had done it that way, we would have been able to skip step 2 here and gone right from step 1 to step 3. So know that you do have that option to manipulate those numbers as needed so that your variable is on the left and any other numbers go on the right. So go ahead and try that idea now on this example. Pause the video and the answer will be displayed shortly. So go ahead and check your work. Hopefully you're critiquing me right now and saying, wait a minute, that answer would not get full credit because it's not in standard form. And if you caught that, you would be correct. I do have it backwards here. I do need to rewrite it and correct that so that it is indeed in standard form. Hopefully you get the idea, so I'm not going to bother right now. But if this were a test or a quiz and that were my final answer, I would only get partial credit because it is technically not in standard form. So that's one thing that we're talking about today with the binomial theorem. That is simply how to expand a binomial without having to do algebra. There are some applications of the binomial theorem that are actually pretty interesting as well. First of all, you can use it to answer questions like, what's the coefficient of x squared y cubed when you expand x plus y to the 5th? Well, let's try to figure out what's going on here. This is x squared y cubed. Now the powers here add up to 5, which is good because I know I'm in row 5. So if I think about all the terms in row 5, the coefficient is what I'm looking for. So I got to figure out what term I'm on. Now x is going to be at the beginning. If I were going to be expanding this, the x would be the first term. So the very first term would have an x to the 5th, then it would descend after that. So let's just list those out and just count them up. So this is going to be 5, choose 0. The next one's going to be 5, choose 1. 5, choose 2. And this is going to be 5, choose 3. So by the time I get to x to the 2nd, there will have been 3 previous terms to get me there. So the 4th term in on the 5th row is what I'm looking for. So let's write a little note there. 4th term in row 5. So if you know row 5, let's list it out. We know it's going to be 1, 5, and I have this memorized because we had done it earlier. 1, 5, 10, 10, 5, 1. 4th number in is 10. So my answer there is 10 for my final answer. Another way we can use it, which I'm sure once you've seen it, you'll probably kick yourself, because this would have been another way we could have answered our coin toss questions from earlier this year when we did probability the first time. If a coin is flipped 5 times, how many of the possible outcomes have at least 2 heads? Back when we did this question the first time, we listed out all the possibilities. For example, heads, 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 heads. Then we would have introduced one coin being different, tails, heads, 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 heads. Then the tails moves to the 2nd position. then the tails moves to the third position, and so on. And I know for a lot of students making that list was super tedious, so I want to show you how you can use the binomial theorem to help you answer that question. And actually, let's leave that there. If you think about the coefficients of Pascal's triangle in row 5, so let's think about this as x plus t, heads plus tails, as being our binomial, and us raising it to the 5th power. When I generate my answer here, I would get 1, 5, 10, 10, 5, and 1, because I'm in row 5 and those are the coefficients from the triangle. My h here would be the first term that I would put in. That would be h to the 5th, h to the 4th, h to the 3rd, h to the 2nd, and h. Let's go ahead and fill in the tails as well. No tails at the beginning. Or let's actually start on the right. Tails to the 5th, tails to the 4th, tails to the 3rd, tails squared, and tails. Now if you think about what that answer represents, this is just another version of the list that I had started making in this question. How many outcomes have all 5 coins being heads? Isn't there one outcome that's all heads, which is what the coefficient is on the heads to the 5th? There would be, if I had finished my list, 5 outcomes that have 4 heads, 1 tails. There would be 10 outcomes that have 3 heads, 2 tails, and so on. So the coefficients actually count for you what the outcomes were going to be. So if we're looking for at least 2 heads, we want 2 or more. So I want to look for h to the 2nd and everything higher than that. So h to the 2nd occurs here with 10 outcomes being 2 heads, 3 tails. We got 10 outcomes where it's 3 heads, 2 tails, 5 outcomes for 4 heads, and 1 outcome for 5. So let's add those up. 10 plus 10 plus 5 plus 1 is 26. So rather than making the list, I can do the binomial expansion or the binomial theorem and just count the coefficients for what I'm looking for. I love that question because it actually helps me realize that when we did the list before, we were doing preparation work for what we're doing here with the binomial theorem. But the binomial theorem is a much simpler way of answering the question. Students do need a bunch more practice with the binomial expansion or the binomial theorem, so I want you to try numbers 2 and number 6 from the homework right now. Try to attempt these without using your notes. You can consult Pascal's triangle to get your coefficients because you'll have that available on your next quiz. Pause the video, give these 2 a try. And so your answers here, you won't need the 1 at the beginning and the end, but the rest of that is in standard form. And then down here, I've got the final answer listed. If you have any questions on why these answers are the way that they are, feel free to ask during class.